Hello everyone, I am Hazik Kirmani and this is one more video for the advanced illustrations of the PYQs of JEE Advanced. These are going to be the most expected questions you can expect in both mains as well as advanced sometimes. And let's discuss one more problem on Newton's laws of motion. In this we have been given two particles of mass m each are tied the ends of light string and they have a distance of 2a between them. Fine, so 2a is between them. The whole system is kept on a frictionless horizontal surface. So basically they are kept on this horizontal surface that you have to visualize. So this is one system, this is one plane. Okay, this is one plane. Now what happens is with the string held so tight that the mass are at a distance of a from center P. Okay, now the midpoint of the string is pulled vertically upwards. So this is going in some z plane now, isn't that? Two masses are in xy plane and this force is in z axis now, out of the plane. Fine. Small constant force F. As a result, the particles move towards each other on the surface. Okay, so can we say basically the force is upwards. One second, the force is upwards. This is the force. Okay, and for example this is our plane. Fine, these two masses are in the plane and they have only the acceleration towards each other. So this acceleration we will call it A, and because this block is on the horizontal, it will have a normal, isn't that? And there will be a tension force that will pull it. One more thing will be there, that is mg, and for example this is theta. Okay, fine. First of all, if this is t, this will also be t. So can we write, and this is 90 minus theta basically, can we write basically t cos theta in this component, but it is 90 minus theta to t sin theta, and same for this component also. This t component in this direction will be sin theta again. So 2t sin theta is F, isn't that? Because the components of tension in this axis cancel each other. So we got this one equation, and the second one we'll get from the free body of either of the masses. So can we write the t, this t sin theta plus normal, this is the upward force, it should be equivalent to mg. Fine, because in the vertical plane, okay, in the vertical plane there is no motion, the only motion is in horizontal plane. And what are the forces in the horizontal axis? Can we write t cos theta is basically the only force that is pulling this mass towards this direction. Okay, two masses towards each other, the only force acting in the horizontal direction is t cos theta. That for one body, that should be equivalent to mass times acceleration, isn't that? That acceleration we have to find. So do we know force now? Okay, sorry, t. Can we say t is nothing but F divided by 2 sin theta? Okay, can we put this t in this equation now and write F by 2 sin theta, and cos theta should be equivalent to mass times acceleration, isn't that? So what is acceleration now? F by 2m cot theta. This is our acceleration. And what is cot theta? From this triangle we can calculate that. Okay, if this is, okay, that is given the magnitude of acceleration when the separation between the masses becomes 2x. So in this triangle, if we take one of the triangles, it is x basically, because the total distance is 2x now, isn't that? This is right angle triangle and this remains a always, isn't that? Because initially it was like this, a, and then it moved like that. So this is also a, isn't that? Not in this triangle, because this string is moving basically. Fine. So if this is a, can we say this is a square minus x square under root? Yes. And what is cot theta now? Cot theta is F into x divided by basically base divided by perpendicular, that will be 2m root of a square minus x square. Let's see, where is this? Okay, this is your option. fx 2m a square minus x square. So this is a good problem, especially for visualization, and I hope I'll see you in some more awesome problems. Till then, see you.